The question we are solving now belongs to test series 5. It is of control system subject. In specific, it belongs to Nyquist analysis. As per the question, the open loop transfer function of a unity negative feedback control system is given as 1 by s into 1 minus 2s. We need to find the Nyquist plot of this control system. Upon substituting s is equal to j omega, we see that g of j omega multiplied by h of j omega can be written as 1 by j omega into 1 minus 2j omega. Now let us multiply and divide this by 1 plus 2j omega. So upon simplification, this becomes 2 omega minus j divided by omega into 1 plus 4 omega square. So in the real and imaginary form, this can be written as 2 by 1 plus 4 omega square minus j divided by omega into 1 plus 4 omega square. Now for finding the Nyquist plot, if we substitute omega equal to 0 plus g of j omega, h of j omega takes a value of 2 minus j infinity, and as omega tends to infinity plus, this takes a value of 0 minus j0. Also we see that the real part of g of j omega, h of j omega is 0 at omega as omega tends to infinity. Similarly, imaginary part is 0 as omega tends to infinity. It means that the Nyquist plot intersects the real and imaginary axis as omega tends to infinity. From this data, the Nyquist plot of the control system as omega is varied from 0 plus to infinity plus can be plotted as shown. Now due to the symmetry, as omega is varied from infinity minus to 0 minus, the Nyquist plot can be obtained as shown. Now we see that as omega is varied from 0 minus to 0 plus, the amount of encirclement of the Nyquist plot around origin is given as minus n pi, and this encirclement will be in the clockwise direction, where n is a type of the system, and for the given system n is 1. So this can be written as minus pi, and the amount of encirclement should be clockwise. So from this we see that the Nyquist plot as omega is varied from 0 minus to 0 plus is as shown, and it makes a encirclement of pi around origin. So from this we see that the Nyquist plot that we got matches with the one which is in the option D. Hence the correct option which represents the Nyquist plot of the given control system is D.